Welcome back, everyone. So, we will continue with control manipulation, 2D object manipulation, and 3D object manipulation. So, let's just highlight this. Um, Many controls, particularly menus, require the moderately difficult motion of a click and drag rather than a mere click. This direct manipulation operation demands more of users because of its juxtaposition of fine motions with gross motions to click, drag, and then release the mouse button. So basically, you want to reduce this click and drag if you can use click, just like with the double click. There is no solution to this problem other than to provide additional idioms to accomplish the same task. If a function is available from the menu and it's one that will be used more than just rarely, be sure to provide idioms for invoking the function that don't require a click and drag operation such as a toolbar button. So the solution here is to provide additional idioms. If your functions inside the menu will be provided more than just rarely, you need to provide an idioms for invoking that function without requiring them to go through it uh, with a click and drag, such as a toolbar button. So instead of menu, but we knew that menu is not in the modern application. We usually use sidebar. So we need to use like that toolbar button that will allow us to immediately click it. So we don't want to drag that. So as soon uh, as much as possible, we want a click map to it. One nice feature in Windows, which Mac OS has also adopted, is the ability to work its menus with a series of single clicks. Rather than clicking and dragging. You click the menu and it drops. You point to the desired item, click to select it, and close the button. So once you click on the toolbar, it drops on the main content area. And then once you select that, once you click that, it becomes selected. And then if you close that, it immediately closes. Microsoft further extend this idea by putting application into a sort of menu mode as soon as you click any menu. In this mode, all the top level menus in the application and all the items on those menus are active, just as though you were clicking and dragging. So another mode or solution to that is providing a menu mode in which when all the menu will be a single click away um, to be provided in the main content area. First, modal tools and palettes. With modal tools, the user selects a tool from a tool palette. As discussed earlier in this chapter, the application's display area is then completely in that tools mode. So once you click the tool palette, this main content is that on that tool mode. So that's the menu mode that are talking about. It does only that one tool job. The cursor usually changes to indicate the active tool. When the user clicks and drag with the tool on the drawing area, the tool does its thing. So the tool could be a function. That's why when you click and drag that tool, so such as here when I drag that here, it does its function. So those are the tool pali, but there's some new ones here. The cursor usually change. So we mentioned that we need to rarely change the cursor, but in this case, we need to change it a little bit to uh, indicate that we have clicked a function or an object from that tool pali. The tool can be used repeatedly, spraying as much ink as the user wants until he clicks a different tool. If the user wants to use some other tool on the graphic, like an eraser, he must return to the toolbox and select the eraser tool. So since that tool is activated and you want to activate another tool on the tool pali, you need to click the other icon for the eraser tool. The application then enters eraser mode, and on the canvas, the cursor erases things only until the user chooses another tool. There is usually a selection cursor tool on the pali to let the user return the cursor to a selection-oriented pointer, as in Adobe Photoshop, for example. So there's a way for you to revert things to a point to choose in a choose mode in a menu, such as in Adobe. If you are currently want to diminish the icon or tool that you have chosen. Modal tools are not bothersome in an application like Paint, where the number of drawing tools is very small. In a more advanced drawing application such as Adobe Photoshop, however, the modality is disruptive. As users get more agile with the cursor and tools, the percentage of time and motion devoted to selecting and deselecting tools, the exercise increases dramatically. So it may be good to do that, to deactivate other tools while you're using other tool, but for a complex authoring tools like Adobe, it becomes an exercise for intermediate users. Modal tools are excellent idioms for introducing users to the range of features of such an application, but they usually don't scale well for intermediate users of more sophisticated applications. Luckily, Photoshop makes extensive use of keyboard commands for power users. The difficulty of managing a modal tool application isn't caused by the modality as much as it is by the sheer quantity of tools. So the difficulty of modal tools or menu is the sheer number of tools or icons that is needs to be learned there. It's not that you need to click the modal just like the menu. More precisely, the efficiency breaks down when the quantity of tools in the user's working set gets too large. A working set of more than a handful of modal tools tends to become hard to manage. If the number of necessary tools in Adobe Illustrator could be reduced from 24 to 8, for example, its user interface problems might diminish below the threshold of user pain. To compensate for the profusion of modal tools, products like Adobe Illustrator use modifier keys to modify the various modes. So, to remove those confusions, since there's a lot of tools that makes it difficult for intermediate users, the Adobe provide a modifier tools or a shortcut key to enter into those modes or into those pali. The shift key is commonly used for constraint drugs, but Illustrator adds many non-standard modifier keys and uses them in non-standard way. For example, holding down the Alt key while dragging an object drags away a copy of that object. But the Alt key is also used to promote the selector tool from single vertex selection to objects selection. So the Alt key are also are used for dragging an object away a copy of that object, like copy and paste. But also, it is also used to promote the selector tool or the icon from the tool palette from a single vertex selection to object selection. So it could be jump. You could jump from a single vertex that you used to click that, for example, image like this. When I click that here, these are the single vertex to another object using Alt in Adobe Illustrator. So the distinction between this is subtle. If you click something and then hold down the Alt key, you drag away a copy of it. Alternatively, if you hold down the Alt key and click something, you select all of it rather than a single vertices of it. So if you hold down the Alt and then click something, you select all of that rather than just a single vertex of that image. And then if you click something and then hold down the Alt key, so if you click first before Alt, you drag away a copy of it. But then to further confuse matters, you must release the Alt key or you will drag away a copy of the entire object. So if you press Alt and then click, you must release the Alt. To do something as simple as selecting an entire object and dragging it to a new position, you must hold down the Alt key, point to the object, click and hold down the mouse button without moving the mouse, release the Alt key and then drag the object to the desired position. What were these people are thinking? So those are bad design decisions. Charge cursor tools. With charge cursor tools, user again select a tool or shape from a palette. But this time, rather than switching permanently until the user switches again to the selected tool, the cursor becomes loaded or charged with a single instance of the selected object. So instead of deactivating the tool, the currently used tool, from a tool palette, when you click on an icon on a tool palette, it created an instance. So kind of like this, I think, drawing. When I put it here, no. But there's some object that acts like that. When the user clicks in the drawing area, an instance of the object is created on the screen at the mouse up point. So if you release the mouse, the charge cursor doesn't work too well for functions, even though Microsoft uses it ubiquitously for its format painter function, but is nicely suited for graphic objects. So it is not suited for a function like a print function, but it's suited for a graph objects. PowerPoint, for example, use it extensively. The user selects a rectangle from the graphics palette, and the cursor then becomes a modal rectangle tool charged with exactly one rectangle. I think there's that option here in insert space. No, actually not. Insert file pictures. Where is that? So I think you have, that when you're using PowerPoint. So let's just focus on other topic. In many charge cursor application like PowerPoint, the user cannot always deposit the object with a simple click. So some charge cursor application, so a cursor is like when you click a text box or a box in a PowerPoint, it create an instance of that you can put in the content area. So in some application, the user cannot always deposit the object with a single click. Instead, she must drag a bounding rectangle to determine the size of the deposited object. So sometimes the user needs to configure the box. There's no default size. Some applications like Visual Basic allow either method. A single click of a church cursor creates a single instance of the object in a default size. The new object is created in a state of selection, surrounded by handles, which we'll discuss later in the section resizing and reshaping, and readily for immediate precision reshaping and resizing. So once we create an instance, that's when we can reshape or resize. So that's the uh, attributes of other application that implement this mapping. This dual mode, allowing either a single click for a default size object or dragging a rectangle for a custom size object, is certainly the most flexible and discoverable method that will satisfy the most users. Sometimes charge cursor applications forget to change the cursor's appearance. For example, the Visual Basic changes the cursor to crosshair when it's charged. Delphi doesn't change it as well. Another thing is that these charge cursor tools are the innovation from Toolpalay that disable the other tool once you one or click. So for complex authoring tools like PowerPoint, these cursor-based tools are more appropriate. And then also you need to provide pliancy to indicate that you have clicked it, because some do not provide pliancy. If the cursor has assumed a modal behavior, if clicking it somewhere will create something, it's important that it visually indicate the state. So since it's a modal behavior, again, a modal behavior are usually hidden in this Toolpalay now, or sometimes it's actually a dialog box or less frequently used function before. Then you must provide a pliancy that visually indicate the state. A church cursor also demands good cancel idioms. Otherwise, how do you harmlessly discharge the cursor? Pressing the escape is one widely used and effective discharge idiom. So escape or the commonly idiom for that. 2D object manipulation, like controls, data objects on the screen, particularly 2D graphical objects in drawing and modeling applications, can be manipulated by clicking and dragging. So 2D, like this LCD, the icons or controls or functions here is all the same as the data objects on the screen, particularly for drawing and modeling applications that can be manipulated by clicking and dragging. Objects other than icon, which were discussed earlier in this chapter, depend on click and drag motions for four main operations: repositioning, resizing, reshaping, and connecting. So we can expand the clicking and dragging, since we mentioned it was for transformation. This was actually depend on this four operation: repositioning, resizing, reshaping, and connecting. Repositioning is the simple act of clicking an object and dragging it to a new location. The most significant design issue regarding repositioning is that usurps the place of other direct manipulation idioms. The repositioning function demands the click and drag action, making it unavailable for other purposes. So it's like in the toolbar, when you reposition something, other buttons is not available for activation, because you're currently selecting and dragging or repositioning something, making it unavailable for other purposes. This is not an issue for content in an application, since the direct manipulation is likely intentions of a drag and drop. but it can mean problems for objects in the interface. The most common solution to this conflict is to dedicate a specific physical area of the object to the repositioning function. For example, you can reposition a window in Windows or on the Macintosh by clicking and dragging its title bar. So one of the solutions for this repositioning to indicate that you can do something else other than positioning is that allowing your user to click and drag using title bar. The rest of the window is not pliant for repositioning, so the click and drag idiom is available for functions within the window as you would expect. So uh, so if there's another windows, those are not allowed for repositioning. So the clicking and oh my god, I don't know why it was clicked. So this is not an issue for sorry. So the click and drag idiom is available for functions within the windows you would expect. The only hints that the window can be dragged are its color and the slight dimensionality of the title bar. A subtle visual hint that is purely idiomatic. Thankfully, the idiom is very effective. In general, however, you should provide more explicit visual hinting about an area's pliancy. For a title bar, you could use cursor hinting or a grippable texture as a pliancy hint. Before you move an object, you must select it. This is why selection must take place on the mouse transition. So before you can move the object, you must select it. This is why selection must take place on the mouse transition. The user can drag without having to first click and release an object to select it, and then click and drag it to reposition it. It feels so much more natural to simply click it and then drag it to where you want it in one easy motion. So instead of like holding it, clicking and holding, in one click you are able to drag it. This creates a problem for moving contiguous data in Word. For example, Microsoft uses this clumsy click wait click operation to drag chunks of text. You must click and drag to select a section of text. Wait a second or so, and then and click and drag to move it. So when you click, this is unfortunate, but there is no good alternative for contiguous selection. If Microsoft were willing to dispense with its modifier key idioms for extending the selection, those same modifiers keys could be used to select a sentence and drag it in a single movement. But this still wouldn't solve the problem of selecting and moving arbitrary chunks of data. So there is a modifier key that could be used to select an entire sentence to drag in Word. That's why it's hard to drag things in Word. So since this repositioning could have a problems with objects in interface, because of that, you don't know what windows you would drag it, or what possible. The repositioning function demands the click and drag uh, action, making it unavailable for other purposes. So there is a confusion in this clicking and dragging, because you need to hold it. So there's this technique. When you do repositioning, a modifier key such as shift is often used to contain the drag into a single dimension, either horizontal or vertical. This type of drag is called a constraint drag. Constraint drags are extremely helpful in drawing applications, particularly when you draw neatly organized diagrams. The predominant motion of the first 5 to 10 pixels of the drag determines the angle of the drag. So depending on x or y axis, on 5 or 10 pixels you move the sentence will determine the angle. Some applications interpret constraints differently, letting users shift angles in mid-drag by dragging the mouse across a threshold. So if you drag the mouse across the threshold while dragging it some certain position, it allows you to change the angle from horizontal to um, vertical. So that's useful for drawing applications. Another way to assist user as they move objects around on screen is by providing guides. In the most common implementations, such as Adobe Illustrator, there are special lines that the user may place as reference to be used when positioning objects. So since you don't know where to position object, first solution is Windows, uh, uh, and then title bar, hinting of title bar. Another is modifier key, and this third is a guide on where you could reposition it. Commonly, the user may tell the application to snap to the guides. So again, these are the techniques that allows us to provide click and drag in the increasingly object-oriented world. So this means that if an object is dragged within a certain distance of the guide, the application will assume that it should be aligned directly with the guide. Typically, this can be overridden with a keyboard nudge. So if it align with the guide or on that certain pixel, then the application will assume that it will be aligned directly within that guide, and typically that could be overridden with a single keyboard nudge. A novel and useful variation of this concept is OmniGraphL Smart Guides. They provide dynamic visual feedback on and assistance with positioning objects. So this another technique. It allows you to provide dynamic visual feedback with positioning the object. This is based on the very reasonable assumptions that users are likely to want to align objects to each other and create evenly spaced rows and columns of these aligned objects. So here it provides like a drag candidate that you could provide the object adjacent to or vertically to. Google SketchUp, described in greater detail later, provides similar help with three-dimensional sketches. Resizing and reshaping. The user can adjust a window size and aspect ratio at the same time by dragging a control on a window's lower right corner. So the user can adjust the window size and aspect ratio by dragging this like this of um, resize handle. It's also possible to drag any window's edge This interaction typically are supported by clear cursor hinting. So it's typically supported by hinting like this, that cursor. A resizing idiom for a graphical objects must be visually bold to differentiate itself from parts of the drawing, especially the object it controls. So here, that is visually bold. You can easily differentiate from the uh, object that it controls. Here is the object, the image. It also must not obscure the user's view of the object. So it should not obscure. As you can see, it's not obscuring this image and the area around it. The resizer also must not obscure the resizing action. So this resizer should not obscure the resizing action. As you can see it moving. A popular set of idioms accomplishes this goal, shown in figure 18.23. They are called resize handles, or simply handles. Handles serve double duty because they can also indicate selection. So here it could also indicate selection, because when I clicked it, this resize handle will be will pop up. This is naturally symbolic relationships, because let's see, an object usually must be selected to be resizable. So the handle centered on each side moves only that side, while the other side remains motionless. So a handle that reside only, when you move this, it only move toward that right. So this will be kept constant. The handles on the corners simultaneously move both the sides they touch. So these both sides, all of these sides are being moved. An interaction that is quite visually intuitive. Handles tend to obscure the object they represent. So they don't make a very good permanent controls. So they obscure this because it's so visually um, obvious that it's not. It should only pop up when you click it. It should not be a permanent controls. This is why we don't see them on top level resizable windows. That's also we don't see it here. X, and here we don't see that because it's visually distracting. For that situation, frame or corner resizers are better idioms. If the selected object is larger than the screen, the handles may not be visible. So if a selected object is larger than the screen, so if we like move this up here on the right, these handles may not be visible. So if they are hidden off screen, not only are they unavailable for direct manipulation, but they also useless as selection indicators. So the selected object has 8 handles, one at each corner and one centered on each side. The handles indicate selection and are a convenient idiom for resizing and reshaping the object. Handles are sometimes implemented with pixel inversion, but in a multicolor universe, they can get lost in the clutter. These handles from Microsoft PowerPoint 2010 feature a small amount of dimensional rendering to help them stand out in the slide. Non-rectangular objects display their drag handles in a rectangular bounding box around the object. So non-rectangular objects display their drag handles uh, in a rectangular bounding box around the object. So here is the drag handles. And also there's a dimensional rendering as well to help them stand out on the slide. So here it is easy to notice. As with dragging, a modifier key is often used to constrain the direction of resize interaction. Another example of a constrained drag idiom, shift is again used to force the resize to maintain the object's original aspect ratio. So we use shift to extend it, to drag. At the same time here, it also uses a modifier key to constrain the direction of resize interaction. So it could be in the vertical or horizontal, and then it is also used to maintain the aspect ratio or the size. This can be quite useful in some cases. It's also useful to constrain the resize to either a vertical, horizontal, or lack aspect ratio. Notice that the assumption in this discussion of handles is that the object in question is rectangle or can be easily bounded by a rectangle. If the user is creating an organization chart, this may be fine, but what about reshaping more complex objects? A very powerful and useful variant of the resize handle is a vertex handle. Many applications draw objects on the screen with polylines. A polylines is a graphic developer term for a multi-segment line defined by an array of vertices. So it's an array of vertices that form a polygon. So it's a connection of lines. If the last segment connects back to the first vertex, it is a closed form, and a polyline forms a polygon. When the object is selected, the application, rather than placing 8 handles as it does on a rectangle, places one handle on top of every vertex of the polyline. So here, the user can then drag any vertex of the polyline independently and actually change one small aspect of the object's internal shape rather than affecting it as a whole. So the user can drag each of these vertices to change the independently one small aspect of this object shape rather than changing them as a whole. These are vertex handles, so named because each vertex of the polygon has one handle. The user can click and drag any handle to reshape the polygons one segment at a time. So they can reshape this one segment at a time. This idiom is primarily useful for drawing applications. Freeform objects in PowerPoint are rendered with polylines. If you click a freeform object, it is given bounding rectangle with the standard 8 handles. If you right click the freeform object and choose edit points from the context menu, the bounding rectangle disappears. So a freeform object could be rendered with this polylines as well in PowerPoint. And then if you click the freeform object, it is given a bounding rectangle with the standard 8 handles. Now if you right click the freeform object and choose edit points from the context menu, the bounding rectangle disappear and the vertex handle appear instead. So that freeform rectangle will be replaced by a vertex handle. It is important that both these idioms are available. The former is necessary to scale the image in proportion, and the latter is necessary to fine-tune the shape. If the object in question is curved rather than a collection of straight line, the best mechanism to allow reshaping is the Bezier handle. Like a vertex of a polyline, it expresses a point on the object, but it also expresses the shape of the curve at the point. Bezier's curves require a good deal of skill to operate effectively and are probably best reserved for specialized drawing and modeling application. Connecting. If you use project management organization chart applications, you are undoubtedly familiar with this idiom. For example, to connect one box in a project's manager network diagram, often called upper chart, with another, you click and drag an arrow between them. In this case, the direction of connection is significant. So again, you don't just click, you also hold it and then drag to connect to the next object. The task where the mouse button went down is the front task, and the task where the mouse button is released is the to task. So the from task is where the first object, and the to task is the connecting object. As connection is dragged between objects, it provides visual feedback in a form of rubber banding. So there's like this. You can see the I think we can do that here. No, I can't do this. So it's not an application for that. The arrow forms a line that extends from the first object to the current cursor position. So from that first object, when you drag that, it will follow the cursor. The line is an animated following the movement of the cursor with one end while remaining anchored at its other end. So it will follow the cursor while at the same time anchored or still connected to the first object. As the user moves the cursor over connection candidates, cursor hinting should suggest that the two objects may be connected. So as the user cursor moves the cursor connection candidates, the cursor should provide a hint on what objects it can be connected to. After the user releases the mouse button over a valid target, the application draws a more permanent line or arrow between the two objects. In some application, it also links the object logically. So some application not just link them graphically or visually, but also objectly, such that you can change the attributes of both of them at once when you right click using the pop-up settings. As with drag and drop, it's vital to provide a convenient means of cancelling the action, such as the key or chord clicking. So chord clicking is another idiom for escape. Connection can also be full-fledged objects themselves, with reshapes, handles, and editable properties. So that connection line could also be programmed as a full-fledged objects where you can reshape that line as well into a full form, and then you can edit its properties. This sort of implementation would mean connection could be independently selected, moved, and deleted as well. So you can distinguish that connection, and then it could be selected, move, hold it, and delete it. For application where connections between objects need to contain information, such as a project planning application, it makes sense for connection to be first-class citizens. So for an application that really needs this configuration for each connection, for its attributes, the connection could be programmed as its first class citizens on the main content area. In other words, if the user drags an arrow until it points to some icon or widget on the screen, how can he tell if that icon or widget can be connected to? The answer is to have the potential drop target visually hint at its pliancy. So again, the drop target principle is applied here. This hinting for potential targets can be quite subtle or even skewed completely when all objects in the application are equally valid targets for any connection. Target objects should always highlight, however, when a connection is dragged over them to indicate willingness to accept the connection. 3D object manipulation. So far, however, there seems to be no real revolution, merely evolution of 2D idioms extended into the world of 3D. Most 3D applications are concerned with either precision drafting, for example, architectural CAD or 3D animation. When modes are being created, animation presents problems similar to those of drafting. Again, this is a problems of models. An additional layer of complexity is added, however, in making these models move and change over time. So, the movement and the change over time, such as the modes that these objects and the verb are moving. Often, animators create models in specialized applications and then load these models into different animation tools. Display issues and idioms. Perhaps the most significant issue in 3D interaction on a 2D screen is the lack of parallax, the binocular ability to perceive depth. So that parallax, it's like in the first person point of view, like our ability to sense our surroundings or the depth on where we are on that particular environment without resorting to expensive historic goggle peripherals. Designers are left with a small bag of tricks with which to conquer this problem. Another important issue is one of occlusion, near objects obscuring far objects. So let's say you're looking at some objects far away, some objects could obscure it. So without these navigational issues, along with some of the input issues discussed later, are probably a large part of the reason virtual reality hasn't become the GUI of the future. So again, it's a navigational issue. It provides a lot of excise and then the limited input that we can put to it. Just like in the inputs in mobiles and other technologies. So it's a prevalent issue with this technologies. Multiple viewpoints, nonetheless, the most 3D modeling applications present multiple views on the screen, each displaying the same object or seen from a different angle. So it's like in networks, different angles. Typically, there is a top view, a front view, and a side view, each aligned on an absolute axis, which can be zoomed in or out. There is also usually a fourth view, an orthographic or perspective projection of the scene, the precise parameter of which the user can adjust. So there is a fourth view aside from top, front, and a side view. It's like an orthographic, it's like a perspective projection of the scene, the precise parameters of which the user could adjust. So where you are on that like third person point of view or in the because for the front view, it's usually for first person point of view. Per side view, it's also for the first person, but for the top view, you're looking at the third person, but at the same time, the zoom in and zoom out from that third person point of view is this orthographic sorry, what's that view again? Yeah, orthographic projection of the scene, so the precise parameters of which the user can adjust. When these views are provided in a completely separate windows, the front, the top, the side, each with its own frame and controls, this idiom becomes quite cumbersome, so it provides a lot of navigation exercise. Windows invariably overlap each other, getting in each other's way, and valuable screen real estate is squandered with repetitive controls and Windows frames. So it again present the issues with uh, Windows management, just like in this 2D, because you have a lot of view and a lot of same controls in the same in four different window. A better approach is to use multi-pane windows that permits 1, 2, 3, and 4 pane configuration. So the 3 pane configuration has one big pane and two smaller panes. So again, the solution is just in one video divided by pane. But here you can provide four and max of 4 panes that you could provide configuration for each view to remove controls that is not frequently used. Now, for 3 panes, you usually have one panes with two smaller panes inside it. So, configuration of this view should be as close to a single click action as possible using a toolbar or keyboard shortcuts. So, since you're trying to manipulate each view using controls of this, you should use a toolbar that could manipulate it using a single click instead of double click or dragging to provide as much as flow and context as possible. The shortcomings of multiple viewport displays is that they require users to look in several places at the same time to figure out an object's position. So you're trying to look at the position in different views in different screen, and then trying to juggle a lot of information in one view that you're not allowed to do the actual work, such as the toolbar in the tool palette that you can configure to use to get the position. So again, because position help us understand things in sequence in its visually. Forcing the user to locate something in a complex scene by looking at it from the top, side, and front, and then expecting him to triangulate in his head in real time is a bit much to expect, even from modeling whizzes. So, because you're modeling this, even if the expert are provided by too much cognitive load, nonetheless, multiple view points are helpful for precisely aligning objects along a particular axis. So this, nonetheless, there's a benefit for multiple viewpoints. Just a moment. So there's an advantage for that different screen for precisely aligning the objects along particular axes. Baseline grids, depth queuing, shadows, and pose. Baseline grids, depth queuing, shadows, and pose are idioms that help get around some of these problems created by multiple viewpoints. The idea behind these idioms is to allow users to successfully perceive the location or position and movement of objects in a 3D scene projected in an orthographic or perspective view. So if you're looking at the third person point of view, these idioms allow you to get that exactly the properties on where you are on that position. Now, baseline grids provide virtual floors and walls to a scene, one for each axis which orient users. So there's a virtual floors like this that allows you to see it in 3D, because in 3D there's like X and Y axis one X, Y, and Z. This is especially useful when it's the case, as is usually the camera viewpoint can be freely rotated. So using a scroll to rotate your viewpoint like a first person helps. So depth queuing is a means by which objects deeper in the field of view appear dimmer. So it's like controlling the deeper objects of view. So the more you are far away as a third person point of view, the dimmer it gets, so you can differentiate what is um, nearer. It's like in our actual vision, it allows us to see what's far away and what's near. This effect typically is continuous, so even a single object surface will exhibit depth queuing. So even a single object that has this axis will give a useful cues about its size, shape, and extent, depending on the position of the object in relative to that object. Depth queuing, when used on grids, helps this ambiguate the orientation of the grid in view. So grids are actually being used as well here. This is that's how useful grid is for X, Y, and Z axis. It helps disambiguate the orientation of the grid in the view. So remember the principle of the design: the position, the orientation, and the color. One method used by some 3D applications to position objects is the idea of shadows. So related to this depth queuing is the shadows, outlines of selected objects projected onto the grids as if light is shining perpendicular to each grid. So this actually um, one method used by 3D applications to position object, again to find the position, is the idea of shadows, which outlines all the objects projected into the grid as if light is shining perpendicular to each grid. So it's like a light that light the X and Y axis into a grid uh, that show the position of the objects on where it is in relation to our orthographic view. As the user moves the objects in 3D space, she can track by virtue of these shadows or silhouettes how she is moving or sizing the object in each dimension. So depending on the properties that she is using to change that particular object in relates to orthographic view that she wants to get then an exact size, because usually for it's for architecture application to get the exact size of it physically, or it's also used in manufacturing, right? You need to get an exact actual size it, so that when it goes out you actually get the actual size in the real world. That's why this precision is important. So the dimension, the sizing of the object, and the position is important. Shadows work pretty well, but all those grids and shadows can get in the way visually. An alternative is the use of a single floor grid and a pole. So those grids, the axis could be distracting. So another and that the shadows could get in the way as well, and then this depth queuing could get in the way. An alternative for that is a single floor grid and pole. Poles work in conjunction with a horizontally oriented grid. So it's usually for a horizontally oriented grid. When the user selects an object, a vertical line extends from the center of the object to the grid. So that object from the center of that object will have a vertical line that will be projected to the grid, to that single fold grid. And as she moves the object, the poles move with it, so that you can know the relative position of that object to know the exact size in the real world. But to remove the pole remains vertical. So the position is constant. That's why it allows you to get the size and the position correctly. The orientation as well. The user can see where in 3D space she is moving the object by watching where the base of the pole moves on the surface as the grid X and Y axis, and also by watching the length and orientation of the pole in relation to the grid or Z axis. So the length of the pole or the object as well would change depending on how far you are with it, right? So the size are actually important as well, because the size of an object depends on how you are in relates to that object. Now, guidelines and other rich visual hints. However, some application, lots of grids and poles may be overkill. For example, Google SketchUp is an architectural sketching application that let users lay down their own drafting lines using a tape measure and protractor. So using a tape and a protractor, they allow the user to draft their lines. As they draw their sketches, they get color coded hinting. So there's a hint in the color that keeps them oriented to the right axis, so that they're still using on the right axis, because that's how architect draw or plan their design. They use axis to know that they're still on the right axis, because it could be hard to track on multiple position orientation at the same time. Users can also turn on a blue gradient sky and a ground color to help keep them oriented. So there could be a color sky that allows you to see how it is related to the sky, and a ground color so you know where the ground is. Because the application is focused on architectural sketching, not general purpose 3D modeling or animation, the designers were able to pull off a spare, powerful, and simple interface that is easy to both learn and use. See figure 18.25. Now, SketchUp is a gem of an application that combines a powerful 3D architectural sketching capability with smooth interaction, rich feedback, and a manageable set of design tools. User can set sky color and real-world shadows according to location, orientation, and time of day and year. So here you add time aside from orientation and color and position and location with respect to X and Y axis. This help not only in presentation but also in orienting users. Users also can lay down 3D grid and measurement guides, just as in 2D sketching application. Camera rotate and zoom functions are cleverly mapped to the mouse scroll wheel, allowing a fluid access while using other tools. So the rotate and zoom are mapped into the scroll. So they can also lay down the grid measurement using a 2D, like in this 2D sketching application. That's why it follows the idioms. So it not only help in the orientation and then providing context and position, but also it's easy to use. Wireframes and bounding boxes. Wireframes and bounding boxes solve problems of object visibility. So bounding is like a box that allows you to see where is the limit, and the wireframes is like the skeleton sketch of the drawing you want to draw. In the days of slower processors, all objects need to be represented as wireframes because computers weren't fast enough to render solid surfaces in real time. It is fairly common these days for modeling applications to render a wrapped surface for selected objects while leaving unselected objects as wireframes. So other objects on the 3D model could be a wireframe, but the selected objects could be a 3D in itself when selected and when changing the properties. Input issues and idioms. 3D applications use many idioms such as drag handles and vertex handles that have been adapted from 2D to 3D. However, some special issues around 3D input, drag thresholds. In a 3D projection, a different kind of drag threshold is required to differentiate between moving along three, not just two axes. Typically, up and down mouse movement translate into movement along one axis, whereas 45-degree angle drags are useful for each of the other two axes. So a 45 up and down is for one axis, while the 45 degree angle drags are used for each of the other two axes, whether it's Y or Z. SketchUp provides color coding hinting in the form of dotted lines when the user drags parallel to a particular axis, such as X, Y, or Z. And it also hints with tooltips, like in a 2D idioms. In a 3D environment, rich feedback in the form of a cursor and other types of hinting becomes a necessity. The peaking problem, because object needs to be in wireframe or need to be otherwise transparent when assembling scenes, it becomes difficult to know which of many overlapping items the user wants to select when she moves over it. So it's hard to program what the user will select, or to design what the user will select when the user hover in this 3D. So locate highlighting can help but is insufficient because the object may be completely occluded by others. Group selection is even trickier. Many 3D applications resort to less direct techniques such as an object list or object hierarchy that users can select from outside of the 3D view. So outside the 3D view, you have a list. Again, the power of this sorting or list. Although this kind of interaction has its uses, there are more direct approaches. One obvious approach is to let users type or speak the name of the object they wish to select. Another might be by attribute. So it's like in searching by attribute. We don't just select search using their name, or we can search by attributes using the search bar, right? Select the screen shape. If the user has bothered to name objects in the interface, their unique ID could also be used. So here, instead, like you have a leeway to remember the unique ID because you're not manipulating like infinite objects. Unlike in searching tools, since most 3D manipulators are performed with mouse, though, this forces a bit mode of shifting that is less than ideal. For example, hovering over part of a scene could open a tooltip-like menu that let users select one or more overlapping objects. This menu would be unnecessary in the simple case of one ambiguous object. So this menu in this tooltip will be distracting for just one object. If individual facets, vertices, or edges can be selected, it should hint at its pliancy as the mouse rolls over it. So if that facets, vertices in a 3D modeling, then you can program vertices and then edges to be selected and to be pliant as the mouse rolls over it. SketchUp has mapped both zoom and orbit functions to the mouse scroll wheel. Spin the wheel to zoom in toward or from the central 0 point in 3D space. Press and hold the wheel to switch from whatever tool you are using to orbit mode. When you click the scroll bar, it actually switches mode to its orbit mode, which allows the camera to circle around the central axis in any direction. So it will center around on the center or perpendicular axis in any direction. Object rotation, camera movement, rotation, and zoom. One more issue specific to 3D application is the number of spatial manipulation functions that can be performed. So there's a lot of objects and spatial that can be performed here. That's which is one of the issue. Objects can be repositioned, resized, reshape in 3 axes. So it's not just 2 axes, just like in 2D, but in 3D, where you can do this repositioning, resize, and reshape. They can also be rotated in 3 axes. Beyond this, the camera viewport can be rotated in place or revolve around a focal point, also in 3 axes. Finally, the camera's field of view can be zoomed in and out. Not only does this mean the assignment of modifier keys and keyboard shortcuts is critical in 3D application, but another problem also occurs. It can be difficult to tell the difference between camera transformation and object transformation by looking at a camera viewpoint. So it's hard to know that if you're clicking and dragging a object or a camera, especially if you're looking at it at a camera viewpoint. So it's just scroll bar, even though the actual differences between the two can be quite significant. One way around this problem is to include a thumbnail absolute view of the scene in a corner of the screen. So a corner of the screen could have a thumbnail or a small picture that shows what the scene is. It could be enlarged or reduced as needed and could provide a reality check and global navigation method in case the user gets lost in space. So in that scene, it allows the user to provide a context on what is actually is using that small picture. Note that this kind of thumbnail views is useful for navigating large 2D diagram as well. Again guys, thank you for watching and see you in the next video. Peace.